Okay, let's start by declaring a variable of type byte and call it number. Now we want to display it on the console. So as you remember from the last lecture, we type console dot writeLine and put the variable here. Note that as I was typing console.writeLine, my ReSharper plugin automatically added this using statement on the top. System is a namespace, and console is a class that is defined in the system namespace. So in order to use the console class, we need that declaration here on the top. If you're not using ReSharper, you have to go here and manually type using system semicolon. Okay, now take a look at this number here. It has a red underline. And if we put the mouse cursor here, it says local variable number might not be initialized before accessing. If you remember from the slides, I told you in C# before you can access a variable, you need to set it. You need to initialize it. And that's the reason here we have the red underline. We cannot display the number on the console before initializing that. So if I try to compile the application, we're going to get an error. To compile an application, you press Ctrl, Shift, and B. And here is the error list. Use of unassigned local variable number. We can solve this problem by initializing number, like setting it to 2, for example. And you see the red underline is gone. We can compile again, Ctrl, Shift, B. Build succeeded, take a look here. Okay, now we can run the application by pressing Ctrl and F5. Okay, so we got 2 on the console. Now let's extend this example and declare a few more variables. We can define an integer, int count equals 10, and a float, say total price equals $20.95. Now note this red underline here. Let's find out what's happening here. So I put the mouse cursor here. It says cannot convert source type double to target type float. If you remember from the slides, I told you by default the C# compiler treats real numbers like this one here as double, whereas we are declaring a float. So here we need to explicitly tell the C# compiler to treat this real number as a float, and we can do that by appending an F at the end. So the error is gone. Let's declare character. So char character equals A. Note that in C# we enclose characters by single quote, like here. We can also declare a string. String is not one of the primitive types, and I have covered it in a separate lecture in this course. But for now, let me show you how to declare a string. We just type string, give it a name, first name equals Mosh. Note that with strings, we enclose them in double quote. So that's one of the differences between strings and characters. And finally, let's declare a bool. Bool is working equals true. So with bools, we can either set them to true or false. Both true and false are keywords. As you can see, they're indicated by the blue color here, and they're lowercase. So everything you see here that is blue is a keyword, like static, void, string, class, namespace, and all these data types here. Now let's display these variables on the console. So let me show you a trick. Instead of writing console.writeLine, we can do a shortcut. This is what we call a code snippet. So we type CW, that is short for console, writeLine, and then press tab. And Visual Studio automatically converts that to console.writeLine. There are various code snippets that help you write code faster, and I will try to point them out throughout this course. So let's display count. Now another one, total price, and note that I can just type TO, and here's what we call IntelliSense. It's Visual Studio's auto-completion mechanism. You don't have to type the full name of a type or a variable. As long as the IntelliSense detects that and is highlighted here like total price, you can simply press tab, and there you go. Visual Studio automatically completes that for us. Let's display the character. Same here, I just press tab. Again, I typed only a few characters. You can press tab or enter. And finally, it is working. We run the application by Control and F5. So we got all these values on the console. Okay, now let me show you something else. In C#, we have a keyword called var, which makes variable declarations easier. For example, here, instead of explicitly specifying the data type for each of these here, I can simply type var. And I let the C# compiler detect the data type for this variable here. So let me replace all of this with var. Okay, now if we hover the mouse over the var keyword, we can see the underlying data type. In this case, it's system.boolean, which is the .NET type, which maps to C# bool keyword. How about this one? That's a string. And this one is a character. And this one is system.single, which maps to float in C#. And in the case of count, it's int32, which is integer. And same for number. So the tricky thing here is, by default, C# treats integral numbers as integer. And when you use the var keyword, it assumes that it's an integer. If you really want to go for a byte, then you have to explicitly specify it as byte here. But telling you from experience, it's safe to use integer in most cases. In fact, if you look at the classes in the .NET framework, in most cases, integer is the data type used for representing integral numbers. Okay, I revert this back. Now I show you something else. So let's take a look at this one here. So it's a char, which is a character. We can put the mouse cursor here and press Control and then click. That opens the Object Browser window. Take a look here, it's Object Browser. And it's a way to look at the various classes in your project or in the .NET framework. In this case, because I did a control click on the char or var keyword, this is what we got here. So char is highlighted in the Object Browser. On the right side, you see all the members of the char type. So these purple ones are functions or methods. If you scroll down here, you see two fields here, min value and max value. We'll explore them shortly. And note that here is the declaration of char. Char is a structure. We will cover structures later in this course. And note that it's a member of system namespace. You can click system, and that shows the system namespace as well as all the types defined in the system namespace. So these are part of the .NET framework. Okay, let's close this for now. Let's explore another example. So I'm going to get rid of all the code here. We can simply press Ctrl X on each line. And that deletes all these lines here. Okay, let's do a console.write line. So CW, tab. This time I pass a string here. And I specify two placeholders. And finally, supply a couple of arguments. Okay, let's see what's going on here. So here, what we have is called a format string. It's a kind of string that can be used as some kind of template. So at runtime, what we have here, indicated by curly braces and 0 as the argument, will be replaced by the value we pass here. So 0 represents the first argument after this format string. And 1 represents the second argument after this format string, in this case, byte.maxValue. So let's run this application. We got 0 and 255. And that's the range that you can store in a byte. We can do the same with a float. So CW, tab, a format string, float, min value, float, max value. Run the application. So this is the range we can store with a float. It's a huge number that is displayed using the scientific notation. Okay, now let's take a look at constants. So I get rid of these two lines here, Control X, Control X. We define a constant with the const keyword, const float p 3.14, and we have to put f at the end because it's a float. Now, because we declared p as a constant here, I cannot change it in my program. So I cannot go here and say p equals 1. The compiler is not happy, and that's why we see that red underline here. If you hover the mouse here, it says, read-only local constant cannot be used as an assignment target. It's a little weird expression to understand, but basically, the intention of using constants is to have some kind of safety in your program. So if there are values that should not be changed throughout your program, you define them as constants. And this way, you won't accidentally modify their values.